case of Goal 2, this can be also other sources like brains or national libraries when it comes to creative work, or other knowledge bases which are available on the web. The important thing is that we follow a humans in the loop synchronization approach. That means the final decision is basically made by the editor, who really understands the data, whether it's a conflict or not, and what the consensus is and what the implications of the change are. So we don't really see automatic imports into Wikidata or another Wikipedia version as goal of the project. It's more about to drastically reduce the time Wikipedians would invest in order to fix these issues or spot them, and to make the infobox maintenance faster and just more effective. So I really like this theme of the Wikimania 2019. So having these goals in mind, just briefly want to say how I think we could maybe contribute a bit. So on the one hand, there's goal 4, quality education. We hope that we can increase the data quality of infoboxes and push forward a little bit, so that it allows high quality education, and also that good applications can be written on top of this data in the infoboxes. And as I said, there are like differences in the different Wikipedia versions. I hope that we can reduce this gap a bit. And finally, goal 8 and 9, data is the new oil, knowledge is key. So in every field, whether it comes to smart cities, infrastructure stuff, or economic growth, where decisions have to be made, this knowledge is important. And I think Wikidata, Wikipedia, and addition with DBpedia has really big potential to become one of the biggest free and open knowledge graphs of the world. Yeah, this was about the frame of the project. There's some small user story which I want to conclude the introduction. So this was on our discussion page, and my supervisor or the project manager, he mentioned that the Boys Don't Cry article seems a good starting point for the project, because there are several conflicting information. For example, the publication date of the album was March 15 or March 16, depending on the different versions of Wikipedia. And then immediately, not like 40 minutes later, we got the reply, yeah, he fixed this. There was this discrepancy between the Japanese Wikipedia article and English and French, then the Japanese was updated, but Wikidata was not updated, and now we basically fixed this. And this was quite happy, we were quite happy about that, because this is exactly how we think the process could look like. So you spot the errors, you can have a look at the data which is available, to compare the differences and try to fix them. So now to the more appealing stuff of the talk. So the basic prototype is shown on the right. We call it GFS data browser at the moment. It shows an aggregated view of the values coming from the different different infoboxes of different Wikipedia versions. Given one article, in this case it's the article of ethanol, and then you have the information for one infobox property. In this case it's the name. This is a specific case. But if we go back to the example, user story, you can easily see it in here. So these were, so this data now is a bit outdated because it was based on a DUM. We're working on this as well. But you could see the two different values. So there was, for the release date, there was March 16 and March 15 in Wikidata, and then in English and French, and you can click on it, and then you go to the page and can verify. Okay, there you go. Yeah, this is basically the interface at the moment. How are we? How are we going to integrate it into the workflow? It's a thing which is still into discussion, and this is why I'm also here, to get you involved and the whole Wikimedia community. So we have two drafts at the moment. One is that we have these special icons included in the infobox view itself. So this is a mock-up, so it's not developed yet. So we just created this in our own page. And when you click on it, you can basically get to the same view again. So let's pick, for example, lift elevators count of the Eiffel Tower. So this is a copy from the Eiffel Tower infobox. And then you go get to the view of the Finder again, and then you can see, get redirected to the specific property. So this is elevator count. This is the international translation of the French one and the Serbian one, and you can see that these values are again out of sync. It's 6 and 7, and 7 was actually mentioned by a website. And this website states 8 at the moment. So you can you basically see that it's hard to make some automatic decision, and why it's important to have a user has to have a look on it and to resolve this issue. And the other approach is, I wrote some little user script, and the user script basically can be included in your global GS. So this is also new to me. I'm not whether you're familiar with it, but it's basically you just add it in your MetaWiki, and then it gets automatically imported into all the Wikipedia versions. And you can basically now just get this simple view on top of every Wikipedia page in every language, and you click on it, and you get right there to the information of the specific source, and then can select, for example, the elevator count again, and can just browse through the data. Yeah, this is we're at the beginning of the project, more or less, so this is a really raw prototype. We have some visions how we could basically do this in the future. So one idea is that we have this bit more interactive, so that users can, for example, already check or confirm specific values and downvote or report errors of other values, because we also have to say all the data we're showing is extracted from Wikipedia. And of course it can happen that the extraction is incorrect because of our software has some error or doesn't handle a specific edge case not correctly and stuff like this. We can also imagine that it can be automatically sorted by trustworthiness. So for example, if references are provided, it gets uploaded. Or if it's more recent, or the editor who actually contributed the fact is very trustworthy and stuff like that. But this is all open to discussion and potentially future work. We can also imagine to have some infobox template generator, which then basically generates the infobox out of the values you want to basically include into some Wikipedia article to play back. You can just then copy it. But this is not really easy, I guess, this template suggestion, so there's still a lot of things to discuss. So now let's have a short look under the hood. So how does it actually work? So we're basically starting from all the Wikipedia versions. We download the public XML dumps, or we can also use the Wikipedia API for single articles to do it live or ad hoc. And we basically then run it through a piece of software which we call DBpedia extraction framework. And with the help of mappings, we then extract informations from the different languages and map it to these, map it into a structured format, into an international representation, so that it's not, so that's aligned with the other versions. So as you could see, lift count or elevators count was the same for Serbian and French, but of course in the national versions they have actually different identifiers or names for that in the info box. Then we do so we basically merge the data first, so to have this elevator count from both Wikipedias, and then we do some cleaning, and finally we put some references, because the reference extraction is a bit separate. It's made by our colleagues from Poznan University, and then we play these combined data back into the view which I had shown to you, so the GFS data browser, where the user can then compare and later potentially edit or download or whatever, interact with the data. Yeah, this is handled by MongoDB, but this is technical stuff. We can integrate external data sets also with mappings. We call this data fusion then, let's say music brains or YF, which is the authority files from libraries, for example. And then we can provide another stage, like filter and enrich, to select data which can be done by editors, to basically select candidates which can be ingested into Wikidata then. So this is how we think it could work, so that you say, okay, this should be imported into Wikidata and it gets into a staging area, and then people from Wikidata can pull it or somehow insert it with the primary sources tool. So I mentioned DBpedia a bit. So this is basically the engine, if you would name it like that, behind it. So the extraction workflow is handled by DBpedia. It is a crowdsourced community effort which started in 2007 to extract this data from infoboxes into a structured format which we call RDF, Resource Description Framework. We'll give a short description in the next slide. To make this information queryable, so that you can really write Sparkle queries, which is also available for Wikidata. You can write a Sparkle query which describes the shape of your information you're looking for, and then it basically returns the results. We did this already in 2007. Now the mission changed a bit. Now it's Global Unified Access to Knowledge Graph. We have extended it with some platform which allows to publish and download and integrate data with other data, but that's not the focus of this talk. So, get a more catchy view, what we basically do in very simple words. We just pick like parts of the info box, then we have some mapping, and then we basically get structured information, which you could imagine like a table where this is the key or property information again, and these are the values. But the difference is, unfortunately you cannot see it because of the screen resolution, that this is like already normalized and standardized data. So this is German, right, October, but this now is like a computer, machine readable, computer understandable representation of this date. Yeah, this was the presentation from the interface side, but actually this is how it looks like for the computer. So it reads the raw info box and translates it into another format. And RDF, it's basically like the statement model in the data. So you always have a subject and a predicate, which could be number of employees, and then the value, but you don't have the additional qualifiers and references as in the data. So I mentioned the mappings. This is why it's a community effort, DBpedia itself. So the key to all the extraction and basically to allow this project are mappings. So let's have a short look. This is one example mapping. So you have this latitude for the location, degrees, minutes, seconds, and so on. And of course the computer doesn't really know how to understand this. This is why we have a mapping which is defined here, which says, okay, this is the longitude, degree, minutes, and so on, and then the computer can transform it into another representation. Or let's use this example. So this is area urban square kilometer, and we have basically in our ontology we call it area urban, and you can now generate such a mapping for every language. And then we do another thing. We define the expected outcome, so we say square kilometer, so the extraction framework automatically converts square feet from the American Wikipedia or English Wikipedia, for example, into square kilometer, and that all the data is normalized across the languages. Yeah, we also have the Wikidata extraction. So you basically ask now, why do we do an extraction of Wikidata? The answer is quite simple. Wikidata is quite big and complicated when it comes to property. So if you want to query for companies, you will struggle with it because it's not easy to get all the companies, because there are a lot of different concepts and then some were hidden, and then you have to navigate through the concepts, classes, and so on and so forth. And this is why we also have mappings for Wikidata to map it into our own DBpedia ontology, which makes querying more simple. Of course, there can be no perfect mapping, but at least for the majority of the use cases, this should be enough and really reduces complexity. And this allows us to see Wikidata and Wikipedia in the same spot, to put it in simple words. This is written in JSON, but that's not so important. So one important thing really is when it comes to Wikidata import is that we have a reference extraction. So I'm not sure whether you know the harvest template tool, which is it's a nice tool written by someone from the community, and it allows to basically import specific things of an infobox. So you can, for example, import all the birth dates of all persons from Wikipedia. But the thing is, you're missing the information where this is coming from. In the end, it was imported from the English DBpedia, but that's not a valid reference, right? So you actually want to have the real references. And so this is where this comes into place. At the moment, this is not integrated yet in the UI, so this is really tacky. But in the end, we also try to give our best in order to extract the citations, to get the names when it was retrieved, and the date of the citation when it arrived, and so on. And basically tie this to the actual information. So the actual information was that Facebook is written, or the programming language is C++, and this is the reference for it. Yeah, if you're, I don't know the audience, or your background, so if you're a developer or pro user, all of the services I had shown to you are available on our service, and if you want to write your own applications on top of that, you're welcome. Just ask us if you want to know more details. We have the raw extraction available, which you can just try out. You insert the article and get the data in RDF or TSV. We have this reference extraction I had shown to you. We have a MongoDB, which has all the aggregated information, which drives the data browser I had shown to you, so the prototype UI. And you can even do simple analytical queries, for example. In this, how many minutes are left?
10. 9.
Okay, so then we have time for this.
Yeah.
So you can, for example, write a simple query in the MongoDB query format, which shows how many population or how many articles can we find which have a population total count, and then you get the number over here. So it's for simple analytical queries. There's also the more sophisticated one, which takes a while, so I leave it in the background, which basically queries now all the languages or the articles which have more than 10 different not conflicting, but 10 different values for location numbers. It's still loading because it's a complex query, so I will just, you can also get the data you saw from the UI prototype raw as JSON if you're interested to build something on top of this. So now the query is done, and there you can see, for example, some results. In this case, let's have a look what it actually is. So these are the different values for population. So you can see they changed a bit. It's around 60,000 something. You can also look at what it actually stands for. This is actually quite funny because this is the URL you saw in here. This one is quite similar to the URL shortener which was presented before. So this is our own internal ID, and it uses the Bitcoin alphabet to the URL shortener to represent this. And in this case, it is Fanama. Let's see it in English Wikipedia. Yeah, that's the city where 10 different values for the population are mentioned in 10 different Wikipedias. Yeah, this is an excerpt from a paper which I recently submitted to a conference. I basically try to analyze how contradictory or how good the values are synced. And in this example, we had a look on all the articles from the Catalan wiki. So we only studied articles which exist in this Catalan chapter or Catalan Wikipedia. And then we had a look how many values are existing in other Wikipedia versions for these for these types of, so for example, for persons or for Angela Merkel or Barack Obama, how many other values exist in other Wikipedia versions. And the height of the bar basically shows how many different knowledge another Wikipedia or Wikidata version can contribute. You can see Wikidata has most data, which could be contributed to the Catalan Wikipedia. Then the English Wikipedia has the second most language, and so on and so forth. These are the 20 most contributing languages we selected here, so there are more, but for reasons of presentation I only picked 20. And what you can see basically here is the blue box basically represents the amount of articles which are fully synced.
You get 5 minutes.
Okay, perfect. No, actually I have to correct, not the articles, but for single pieces of information, so entries in an infobox, like location or the population total number. So this piece of information, how many articles are synced across all the Wikipedia versions. So blue means these are all synced, so these are all fine, or all wrong, we don't know, but usually I guess they're all fine. Green means there is some new information, and this is only available in one Wikipedia. So every other Wikipedias don't mention it at all, so they don't have any information about this. At this moment, this can be an error or this can be novel, and this needs to be checked by an editor because we don't know. But we could integrate external data in order to get an impression whether it could be right or wrong. Red means all values from the wiki are not synced, so they're basically unique, so they do not appear in any other Wikipedia version, and they're completely different than the other Wikipedia. So either this is like completely new and a state of the art, or this is like completely outdated, or it's wrong, or I have to also state these values all have to be considered relative, because it can also be an extraction error introduced by the software. So I have to say that. And yellow means it's partially synced. So that means there's some overlap, which is synced, but there's also some part, like the red part, which is unique, doesn't appear anywhere else. Coming to an end, so there are many of open questions which are open questions to the community, which I hope that there will be some feedback. So I don't really know how shall we basically ingest these changes into the infobox. So one approach is fully manual, so the editors only use our interface and then do their own business like they want to do it. Then this, if you remember this generator, this infobox template generator, like this, you basically use this generator and then you copy and paste again manually some entries into the infobox in order to make the change. Shall we write a visual editor extension and then users can install it? how do we actually present the data to Wikipedians? So one approach is the script I had shown to you, the user script. So the user can decide whether he wants to see it or not. The other approach is that the template maintainers include it into their template, and everybody will see it. And we can even add colors like red, okay, have a look at it. Yellow, it's probably okay. Green is perfect. But this is, again, as I said, it can be annoying maybe for people, so we don't know. But the good thing is that all viewers get an impression of the recentness or quality of the infobox. And the template maintainers decide whether they want to include it or not. And again, the visual editor. Yeah, the last part, how can editors find unsynced values? So I could imagine of a list with articles, and interested people can just go through the list and just pick one in order to improve the quality of Wikipedia. Pings, just perform automatic pings on watch list members if something gets outdated. But I don't know, I don't want to spam people, right? So I don't know whether this is a good approach. Or there's a notification in the editor if you save, or if you edit an article and then press save, it does some checkup in the background, and then it notifies you, hey, maybe let's have a look at the infobox. There's something you should probably check. And then to motivate the user to have a look at it. 1 minute. Okay, yeah, perfect. So next steps, I want to introduce, we want to improve the user script. We want to modify the NBA template, as in the mock-up, to see how it could work and whether it will be accepted by the community. We want to include this live refresh, that no outdated data is shown after it's fixed. We want to add these references for the data browser. We want to select some types of domains to basically test the approach. And we're also thinking of a friendly fork of the Harvest template I mentioned. But yeah, augmenting it with DBpedia technology and with these references. So I really appreciate any feedback. We have a mailing list. We have the project discussion page. You can also become a member of our feedback squad. So you can just go to the project board and then subscribe or join, and then you get notified about news, or can also participate in simple evaluation tasks. Do you like the new feature? Do you like the new UI or whatever? You can file a GitHub issue, or just meet me after the talk on the break or tonight. Yeah. Thank you.
Thank you very much.